Hello? Hello. So yun, I don't know kung evening nyo to pinapanood or afternoon or morning, kinabukasan. But yeah, good afternoon guys. And we nakaabot na tayo sa module 7 ng basic calculus ng mathematics core. So, we're on the part of antiderivatives part 1. Ang coverage nun is the definition of antiderivatives, the definition of indefinite integral, the basic integration rules, the upgraded integration rules, and the application of indefinite integral. So yan, let's head on na. Kasi medyo mahaba tong slide na to. 65 slides siya. And medyo nakaka-board pag babasa-basahin ko siya buo. So yan, pasadahan lang natin. But i-discuss ko pa rin naman siya truly and comprehensively. So yan, first part is meron tayong exercise for all of you. So before anything else, please complete this table by finding the derivatives of the given function. So for this for function, kindly send it to me or I will make an assignment na deadline din next week. Isend nyo sa akin lahat ng mga answers nyo for the exercises here or the sample problem. And for this 4, you will get, pag perfect lahat sila or complete lahat sila, you will get a 0.2 points. Okay, and that will be added to your quiz. Okay? So yan. Next is, syempre on the recent slide, we can conclude na yung second column is yung derivatives ng function na nasa first column. So, yung f of x natin is yung derivative ng capital F of x. Then, the vice versa of it is yung first column yun yung antiderivative ng results second column. So, yung capital F of x is antiderivative of f of x. So, derivatives and integral, medyo magkaiba sila. Medyo vice versa lang sila ng isa't isa. So, yung definition ng antiderivatives is function f is antiderivative of f at an interval I when f prime x is equals to f of x for all x in I. And please note that an antiderivative of f, it is called an antiderivative of f, and not the antiderivative of f. So, magkaiba sila ng article. So, in general, once a single antiderivative is known, other antiderivative can be obtained by adding constant or adding the c or the arbitrary constant to the known antiderivative. Kaya meron tayong arbitrary constant c na na-add to take charge of this constant. Kaya may mga memes dati sa integral na pag walang plus c sa answer is mali na, which is true, saying it is needed. Okay guys, it is needed. Next is, let's head on to our indefinite integral. So the process of finding all the antiderivatives of a function f is called antidifferentiation. So sobrang haba siya. So we can call it integration. So the derivatives of f of x with respect to x is equals to f of x. This is equation 1. Then antidifferentiating or integrating f of x produces the antiderivative of form f of x plus c. So pag in-integrate mo yung f of x with respect to x, makuha natin is f of x plus c, which is kabaliktaran lang ng equation 1. Guys, it is sobrang kabaliktaran. It's different. It's typically vice versa of each other. So, para basahin natin yun is the indefinite integral of f of x with respect to x is f of x plus the constant. May narinig kayo asa, normal lang yan. Normal lang. Wala atang video ko na hindi nyo naririnig yung asa. Sa last lesson ko din narinig nyo yung asa. Anyway, so ganun siya pinabasa. But, sometimes, mahirap siya basahin. So, it is not Hindi naman siya kaso sa akin, kung di nyo alam ba sa akin. But, always be, or always make sure, no, once in your life, or twice in your life, kaya nyo basahin yan. Okay. So, if we differentiate an antiderivative f of x, we retrieve the function f of x. Thus, pag nangyari to, is makuha natin is so f of x. So, we can call indefinite integral as integral. Kaya, ayun. And this, erase this part. And yeah. So, on this part, kapag dinrawing ulit natin yung f of x with respect to x is equals to f of x plus c. On the anatomy of this part, or the part of this part is, this is the integrand. This is the variable of integration. This is the antiderivative of x. This is the arbitrary constant. And this is the integral sign. And partial s, because from the term sum. So that is the part of the integral function. So let's head over the basic integration rules. So dati, or last part, meron tayong differentiation rules, power rule, multiple rules, something like that. Same with the integration rules, meron din silang ganun. So, sa una is yung kapag cosine is equals to 1. Kasi integration rule, magiging x plus c. Next is pag by power rule naman, magiging nx raised to n minus 1. But, sa integration rule, magiging x raised to n plus 1 over n plus 1 plus c. Note that n cannot be negative 1. Yeah? Then, pag natural logarithm x, magiging 1 over x. But, pag integral d of x over x, magiging in absolute value of x plus c. Then, for e of x is equals to e of x sa derivatives, while sa integration is dinagdagan lang ng plus c. Sa a raised to x is equals to a raised to x, natural logarithm a. Sa integration rule, magiging a raised to x over natural logarithm a plus c. Note that a is greater to 0 and cannot be equal to 1. Next slide. Pag sine x is equals to cosine x. Next is pag cosine x dito, magiging sine x plus c. Pag cosine x dito, magiging negative sine x. But here we have sine x negative cosine x plus c. Then we have tan x is equals to secant squared x. On here we have pag secant x squared x, yung tan x plus c. Same with cotangent x, magiging negative cosecant squared over x. Then kapag cosecant squared dito, negative cotangent x plus c. So, as you can see, may pattern sila. So, secant x squared, then dito, secant x squared, then yung tan x dito. Yan, turo natin ganyan. Yung tan x dito, right? So, sobrang malapit or sobrang pinagbaliktad lang talaga sila. Same with the secant x, and pag dito secant x, tan x, then secant x plus c. Next slide. Then, ito, cosine x, magiging negative cosine x, cosecant x, multiply to cotangent x. Then, cosecant x, cotangent x, magiging negative cosecant x plus c. Then, may arcsine x tayo dito, being 1 over square root of 1 minus x squared. Then, pag dito naman, dx over square root of 1 minus x squared, magiging arcsine x plus c. Right? So, sobrang baliktad lang talaga sila. Sobrang baliktad. Same with the arctan, the arcsecant x. So, yan. So, note that, You can use this on solving or finding the required integral of a given function, but you need a sufficient knowledge in algebraic manipulation and trigonometric identities to fully find or to fully acquire the integral. I mean, ganun naman palagi sa math. And always remember that same with the derivatives. Some function needed two or more integration rules or IRs. So, as much as possible, familiarize kayo dyan. Same with the derivatives naman. So yan, we have an example. So find the indefinite integral of the following functions. So for number 1, integral of x raised to 7 with respect to x. Then ginamit yung power rule, 7 plus 1, 7 plus 1, x raised to 8 over 8 plus t. So this is the answer of number 1. Next is number 2, is square root of t with respect to t. Then, using lowest exponent, di ba alam natin square root of t is equals to t raised to 1/2. Then we use this. Then we will use power rule. Then some algebraic manipulation. We will have 2 over 3 over t raised to 3/2 plus c. Don't forget letter c or the arbitrary constant. Next is number 3 is dy over y raised to 7 using the law of exponent again. Syempre pag yung exponent is nasa denominator, we can equal siya pag maging negative yung y and wala na yung fraction. So same lang siya dito. Then using the power rule, we will have negative 1 over 6y raised to 6 plus c. Yan. Yan. Nanonote ko lang yung mga possible para hindi nyo makalimutan. Next is same way sa number 3 nangyari. Ginamit ulit natin yung law exponent, then the power rule. Yeah, power rule. Then we'll have negative 2 over square root of theta plus c. So you can rationalize, but sometimes this will do. Next is this. Try this. So for this number 4 is pag na-complete niyan or perfect 0.2. Okay? Next is properties of indefinite integral. So that is theorem 1 for this is the properties of indefinite integral. Same with that din naman. So derivatives is my properties of derivatives, constant multiple rule, sum rule, difference rule, quotient rule, product rule. Same with this. So let f be an antiderivative of f and g be antiderivative of g. If k is constant, then for the constant multiple rule, the integral k multiplied to f of x with respect to d of x, respect to x, I mean, is magiging k multiplied to f of x plus c. So nakita nyo lang na nagkaiba yung f. Since nga antiderivative, then sum rule and difference rule, pinag-add and pinag-minus lang talaga sila. Yan, medyo pinagsama lang. Ganun. Okay. Next is we have proof or proving of this. So, kindly read this para mas maintindihan nyo or mag-grasp nyo yung properties, but I will not truly discuss this, guys, because I'm much more focused to the examples and the application of the theorem itself. Okay, and on to the examples. So, the direction is apply theorem 1 and basic integration rules to find the indefinite integral of the following function. So number 1 is the indefinite integral of 7 with respect to x. Number 2 is the indefinite integral of 1/2 multiplied to the square root of t with respect to t. Then indefinite integral negative 8 over 1 raised to 9 with respect to y. Then the indefinite integral of pi over theta raised to 3 halves with respect to theta. Let's head over the solution. So number 1 is in isolation 7. In isolation natin 7. Then using the basic integration rules, we have 7x plus c, or the constant multiple rule. Next is we have in isolation 1/2, then naging law of exponent. So we will use the power rule, and we will get 1/3 t raised to 3 halves plus c. Next, number 3. In isolated -8, then power rule, then using the power rule, we will get 1/1/8 plus c. Next is number 4. Is in isolation pi, law of exponent, then power rule again, power rule, and yeah, we will have -2 pi over square root of theta plus c. Same in semicolon, you can rationalize that, and you may check your answer by getting the corresponding derivative of the resulting integral. You can do that, and then compare such with the given integral. Don't know if tama yung sagot nyo, but it is not necessary, guys, if gusto nyo lang. Okay, let's head on with the next slide.